I will introduce a basic use case for a data analyst who needs to share data and uses our replica synthesis software to generate synthetic data for that purpose. The motivation here is that the analyst needs to share data with partners or collaborators, or that she is publishing a paper and needs to make a version of the dataset used in the paper publicly available. There is a lot of pressure on researchers to make their datasets available when they publish papers, and replica synthesis can easily enable that. We're going to share a COVID-19 dataset. Let's consider a situation where a public health unit has a dataset that they need to share. The analyst responsible for this task needs to synthesize the dataset and make it available to a broad audience. The COVID-19 dataset is just an example. In fact, this use case is suitable for any type of dataset. The particular dataset we will look at is the database for COVID-19 cases in Canada. The main role here is Claire. Claire is the researcher. She would typically represent a larger organization or a team of analysts. Claire may be the principal investigator in a research study or the lead data scientist at a public health unit. Claire has created a data set, and now she needs to synthesize it so that the data can be shared. The data may be shared with external partners or with other groups within the organization. Another typical scenario is that Claire is about to publish a paper in a journal, and the journal requires her to make the data set available on a repository for others to replicate her analysis. This is becoming a common requirement for publications. Historically, the process of making data available has been complex and required special expertise. That no longer has to be the case. As you will see, generating synthetic data can be straightforward, and Claire can easily create a synthetic data set and make it available to others. On this graph, the blue shaded area is the technology available in the replica synthesis software. We will be showing you all of these elements later on. The box outlined in blue represents activities required in the use case. Claire, who is the data scientist in this picture, uses the Synthetic Cohort Builder tool. The Cohort Builder loads the real COVID-19 dataset and generates a synthetic dataset from that. We will show you how this works shortly. Now, the Synthetic Cohort Builder is a sophisticated and powerful tool with many capabilities, and I'll show you more on that later on. But for this use case, we will only need some of its basic capabilities. Once Claire exports the synthetic COVID-19 data, she can then share that dataset with other data scientists who can work on it and either replicate Claire's work or do some innovative analysis with it. The key thing here is that the users of the synthetic data can use any analytics tools they are used to. They are not limited to tools that would be provided to them in a secure enclave, for example, and the structure of the synthetic data will be identical to the structure of the real data. If a synthetic dataset is of high utility, it should have preserved the patterns contained in the original data, and analyzing the synthetic data should reveal the same patterns that can be found in the real data. In a moment, we will also demonstrate the utility of synthetic data when used for analysis after generating the dataset. Now, Mina will show us how Claire can use replica synthesis to create a synthetic version of this dataset.
Now I will go to the replica synthesis application and show you how to operationalize this particular use case. We will load up the Canadian COVID-19 dataset with about 100,000 cases across the country and synthesize that. Right now, you're looking at the login page for the replica synthesis software. Once you log in, you're taken to a dashboard where you can see the tasks on this software is organized in terms of workflows. I have pre-built 3 different workflows for today's demo purpose. Now let's go to the first workflow where we synthesize the COVID-19 cases. There's really only 3 simple steps in this workflow. In the first step, you load the real COVID cases dataset. Here you can see this is the name of the dataset that I uploaded. And then, because we're synthesizing the entire dataset, so we don't need to do any manipulation on the dataset and can take it straight to the synthesis step. And here are some of the options that you will see when you get to this step. First, there is the synthesis plan. The synthesis plan contains all the information about how each variable is going to be handled. And I should note here that it is optional to upload your own synthesis plan because the software automatically generates a comprehensive synthesis plan by default. However, if you are an advanced user of replica synthesis and you would like to supply your own synthesis plan to achieve more flexibility with the synthesis, you're welcome to do that using this button as well. For this demo, I used the default synthesis plan. And here you have the option of receiving the auto-generated synthesis plan if you're interested in taking a look. I should also explain that every time you run a synthesis workflow, you will automatically receive an email that contains the synthesis report, which I will also show you later on. But that synthesis report contains more information about the synthesis that was done. And also with that, you can choose to ask the software to also run some utility assessments. I will also be explaining the utility assessments in more details later on, but for now, what utility assessment means is the software does some analysis on the quality of the data. And basically that means to check how close the synthetic data is when compared with the original data. So here you have the options of asking the software whether to run these assessments or not. And if you choose to run it, you can choose to receive the results either in a standalone zip file where we provide you all the details of the analysis results, or you can choose to receive it as an integrated part of the synthesis report. I should also mention that with the replica synthesis software, at each step of the workflow, you can click on the block to get a preview of the data that are generated from this step. This will come in handy in the next use case, which I'll show you in more detail. So after the synthesis step, you basically just need to save the workflow and run it. And while the workflow is running, I will show you how to export the data set once the workflow is run. Here I have already built 3 export tasks for this demo purpose. And this first task is using the output of the synthesizing COVID workflow. And here I'm choosing to export the dataset as a CSV file. I save the task, and then all I need to do is to click the download button. And then voila, you have the synthetic COVID data sitting on your laptop.
Now that we have our synthetic data, let's see how it compares with the original data in terms of analytic utility, whether analysis of each of the datasets generate the same results. The first analysis is to simply look at trends in the number of cases over time. The x-axis is the week the case was reported, starting the first week of 2020. The y-axis is the number of cases reported by Toronto Public Health. As you can see, the first cases were reported in early January. This graph has a fitted curve to reflect the trend. While the exact case counts are not identical to the original data, the trend curves are pretty similar. Here we are looking at the age distribution of COVID cases in the province of Ontario. Again, we're seeing very similar age distributions between the real and synthetic data. The overall patterns in the original data are preserved. In both datasets, we're seeing relatively few cases among people under 20, and the most cases in the over 80 group, followed by those 50 to 59 years old. We are now looking at the number of fatalities in Ontario over time. Again, we have the number of weeks since the beginning of 2020 as the x-axis. The number of fatalities peaked around week 15 and then started to decline. The synthetic and the real datasets tell the same story about the general trends of the pandemic. We can see from these examples that the synthetic data does a good job in replicating the trends and distributions that exist in the original data. Although we used a publicly available, relatively simple dataset for the purpose of the demo, this technology can be used to enable sharing of more detailed COVID-19 data as well. Thank you for watching our demo. There is more information on how to reach us on this slide.